We'll proceed calculating maxima minima in 3D. So we talked about calculating maxima minima through double differentiation to know the maxima minima through double differentiation when it is 2D. Now when it is 3D, then how I can estimate that a critical point or extreme point is maxima or minima by double derivative when it is 3D. Then whatever we are talking, whatever we will talk to get the maxima minima in the 3D, same concept will apply in 2D, and then same concept will apply in 4D and so on. So that is one side. Second side is the if equation is kind of one is that we would talk in one first we'll see the 3D and we'll come to a kind of a formula to get the maxima minima through double differentiation, and same concept, same formula we would apply in 2D and then 4D and so on. And then we will also see that how these are useful in polynomial and multinomial equations. So these are the kind of idea that we will proceed on. These concepts what I am going to discuss now, these are not available in any of the book. Means you can check over anywhere, and these concepts are not available in the anywhere in the book. Okay, so now the concept is that how I can find that my the critical or extreme point is maxima or minima. If we saw the 2D, if you saw the 2D, then if double differentiation is negative, then it is maximum. If double differentiation is positive, then it is minimum. Now, then we talked about something called parabola. If I have equation of parabola, that is y equal to kx square, then parabola has global minima and global maxima. If we see the parabola, if you see the parabola either this way or this way, if I find one extreme point that is either minima or maxima, then after that there is no minima or maxima. This is the kind of, you can say, that usefulness or characteristics of a parabola. Parabola, you are great. Means if I know that at this point there is an extreme point, then full region, that region where there is no limit, in the biggest possible region, okay, then there is neither, then you won't find any maxima or you won't find any minima. Parabola, you are great. So if I have a parabolic equation y equal to kx square, that is equation of parabola, but I would find k. If it is positive, then I know that whatever the single extreme point I have through parabola, only one extreme point is possible through the parabola. Whatever single point I have through parabola, I know that that is going to be the minimum. If k is negative, then if k is positive, then it is minimum. If k is negative, then it is maximum. No need to calculate double differentiation. Okay, so that is the concept. Now, can we kind of can I transform my can I transform my equation, my algebraic equation to These concepts are not available in any of them. This is priceless. I mean, can I convert my any equation, algebraic equation, to parabolic equation? If I am able to convert, then I have to find the sign of k. If my equation is fxy, if my equation is fx, y equal to fx, can I mold y equal to fx to gx, where gx equal to kx square? Somehow, can I represent my monomial or polynomial algebraic equation as parabolic equation? If I am able to map it with some k, then done. Okay, or the part, if I have any polynomial monomial equation and I could find extreme point. Okay, so it is going like this. Somehow I could find extreme point, then another extreme point, then another extreme point. I'm talking about the first extreme I found. Around that extreme point, whatever the strip, so if I place a region, closed region, okay, not the kind of not kind of a bounded region. There are two regions. One is bounded region and one is closed region. So from kind of where I find the extreme point, around that I I place a closed region, and that the whatever the equation I am getting, that part can I convert to parabol. Okay, if I am able to that also, converting it to parabola, then looking at the coefficient of the parabola kx square, quickly I can say that this is maxima or minima. So wherever I am finding the extreme point in any polynomial equation, okay, around the extreme point I'll make a closed region, and then the whatever the equation I am getting there, can that part equation I can convert it to parabolic equation. If I am able to convert it to parabolic equation, then I am done. So straightforward, right? Means there is nothing cleverness in it. Because I know that if I have a parabolic equation, then looking at k, I can find the kind of coefficient. It is very similar to like a person kind of people, means students, like kind of especially in some province in India. Okay, so people, means India is kind of a country where English speaking is minimal, means very few only they know English, but still English is in curriculum somehow. And the students, they generally they remember the essay or they mug up whatever kind of they need to write in the examination. So like if some essay comes, that can you write essay on this, or on this topic can you write something, then generally people they think that these are the topics that will come in the examination, so they mug up, they remember. So like kind of people, the students in some examination, so it was almost sure that a kind of football match, soccer match, football match would be the topic of essay in this exam, English examination. So everyone, they mugged up one football match essay. Like there are 22 players, and then 11 player one side, 11 player one side, and then one goalkeeper, and then midfielder and defense and attacker or whatever, and then how referee, there is two referee, and how they start the match, and how goal happens, and they mugged up everything. But when they went, they went to examination, then means the essay topic was not the football match, it was journey by aeroplane. And everyone came out with the pale face in a way, because they did not mug up, they did not kind of, they tried to put in their brain that aeroplane journey by aeroplane. Well, they did not know that it will be journey by aeroplane, but one guy is happy. Now they asked that why you are happy when we could not write anything. How come you wrote? He means, did you know that it will be journey by aeroplane? He said no. Even I mugged up kind of football match only, but I wrote in a fashion that there is journey by aeroplane and there is some problem in aeroplane somehow, and then the pilot is forced to make an emergency landing. Okay, and he could successfully land the aeroplane somewhere, and there was a football match that was going nearby, and then we went to see the football match, and then he wrote the full essay about the football match. So that is the story here. So whatever if I know that if I have a parabolic equation and looking at the coefficient of parabola, quickly I can say that it is maxima or minima. Then can I convert any equation for which I want to, if I have extreme point and I want to know it is maxima or minima, then I can transform it to parabolic equation and quickly I can say that it is maxima or minima. Straightforward. Okay, now we will proceed and how we can kind of think about a algebraic equation. Consider that I have a monomial equation y equal to fx where fx equal to x, y equal to x, y equal to alpha x, y equal to alpha x, y equal to alpha x is the equation of a line. Y equal to alpha x plus y equal to alpha x minus beta is the equation of line that is passing through origin. Since it is minus bit, alpha x plus beta, alpha x plus beta. Then if the line was passing through origin, then beta means we shifted it beta along the y-axis. A line I can shift anyway. Okay, means vector of the line would remain constant. I mean, the direction of the line remain constant, but I can shift anyway. So if I have a line that is y equal to alpha x, y equal to alpha x, and if I make shift of beta along the y-axis, then it becomes y equal to alpha x plus beta. Anyway, y equal to alpha x is the line. Now, can I duplicate this line? That is the question. Can I duplicate this line through some way? Now, if you see the closely, if I differentiate it, okay, dy by dx, then k remains, where x has power of 1. If x has power of 1, if I differentiate it one time, since x has power as 1, then dy by dx equal to k, equal to alpha. If dy by dx equal to alpha, then can I write this line? Okay, now I have dy by dx. Can I make an algebraic equation where y equal to dy by dx x, y equal to dy by dx x, okay, where dy by dx we have seen it is alpha. So I can replace it with alpha. So y equal to alpha x. So now I have an equation of a line that is y equal to, if fx is alpha x, then gx is another line which is dy by dx x. If that is the case, then I have an equation of a line that is gx. If fx is alpha x, then gx is dy by dx x. Then it is again alpha x. Can you see it? If y equal to if y equal to 50t, if y equal to 50t, then dy by dt is 50. Now can I go with another equation gt, where y equal to dy by dt t, where dy by dt is 50. So y equal to 50t. We could reproduce the monomial equation of algebra through dy by dx. Can you see it? if I have a polynomial y equal to alpha t square, y equal to alpha t square, then if I differentiate its if it is t to the power 2, then if I differentiate it 2 times, then it becomes y equal to 2 alpha 2 alpha. Okay, first differentiation is y equal to 2 alpha t. Second differentiation is 2 alpha. Now, if I have d2y by dt square as 2 alpha, then can I write it now another equation of algebraic equation gt as d2y by dt square into t square? Okay, if d2y by dt square into t square. Now d2y by dt square is 2 alpha, then it is 2 alpha t square, where the original equation is alpha t square. But if I create another polynomial equation with differentiation, then y equal to dy by d2y by dt square t square, then it becomes 2 alpha t square. Original is alpha t square, now we have 2 alpha t square. So I would claim that d2y by dt square into t square divided by 2. If I do like this, then I can represent the same polynomial equation of degree of 2 with the differentiation. Now there is another one. Ft equal to alpha t to the power 3. If that is the case, then if I do triple differentiation, d3y by dt cube, y equal to alpha t to the power 3, then d3y by dt cube equal to 3 into 2 alpha, that's it. dy by dt is 3 alpha t square. d2y by dt square is 3 into 2 into alpha t. d3y by d3y by dt cube is 3 into 2 into alpha, 6 alpha. Now, can I reproduce this with another equation? So, can I say gt, that is ft, now gt, y equal to gt equal to d3y by dt cube, d3y by dt cube t to the power 3. If that is the case, then it comes as 6 alpha t to the power 3, where the original is alpha t to the power 3. Then I have to divide by 6. Can you see it? If it is t to the power 1, then I need to divide by nothing, means divide by 1. If it is t to the power 2, then I need to divide it by 2. If it is t to the power 3, then I need to divide it by 6. 3 into 2, 1, 2, and then 1 into 2 into 3. If t to the power 4, then can I divide by 1 into 2 into 3 into 4? This proves that if I have a polynomial equation, algebraic equation, and it has a single power, either it is t to the power 2, it is t to the power 3, it is t to the power 4, I can reproduce the exact polynomial equation in a function of derivative. Okay, so if I have alpha t to the power 3, then same ft can be represented as another algebraic equation gt, where it is d to the power d to the power 3 y by dt cube t cube divided by, if it is q, 3 t to the power 3 q t, not t cube, t to the power 3, then it is 3 into 2 into 1. So, if I have a polynomial equation ft equal to alpha t to the power n, then I can represent that equation gt in form of differentiation gt equal to d to the power ny by dt power n into t to the power n divided by n factorial. Then I can get back the same equation. If I have interception on y-axis or I have shifted it y-axis beta, then I can just add beta over it. So beta plus d to the power n y by dt power n t to the power n divided by factorial n alpha plus. So alpha plus is out. Now in braces d to the power d to the power n y by dt to the power n t to the power n multiply divided by inside the braces factorial n. If that is the case, then I can represent the polynomial through the differential equation. Exact. Okay, this is the invention and this is available. I did not know. Okay, so this is the invention that any function you can represent as differential function in this form. So slowly we'll see that how we can use to find the maxima or minimum. So this is kind of a function. Now suppose that I have ft as a line. If ft is a line, then single line equation, that is gt dy by dt in form would work. If ft is is polynomial in the form of t square, if ft is form of t square, ft is in form of t square, then can I represent it with the single line? This is another scenario. I have a curve. If it is a curve, then certainly it is not a line. If it is a curve, then certainly it is not a line. If it is not a line, if it is a curve, then it is a polynomial. It has degree more than equal to 2 or more than 2. If that is the case, then if it is y equal to alpha t square, this is the ft. Now, if I represent it as gt, where y equal to dy by dt t, dy by dt t, if that is the case, then it will be 2 alpha t. Can I represent that? If I have the basic function equation in power of 2, then can I represent in power of 1? We can represent with gt. Now new is gt and first is ft, that is alpha t square. Now I have gt, that is 2, that is dy by dt t, where it is 2 alpha t. Both are same, alpha t square and 2 alpha t at some point. Otherwise they are not same. If I have a curve, then this is a line. Y equal to 2 alpha t is a line, where y equal to alpha square t is a curve. If that is a curve and this is a line, that if they are same at a particular point, then at that point it has to be tangential. So a polynomial of any power, power of 2, 3, 4, 5, 6, 7, 8, any power, can be represented using a monomial or a single line when they touch at a point. So at that point, they would be same. So approximation of a polynomial equation can be done through a single line at a point where they meet. At that point, they are same. Otherwise, it is considered as tangential. So if I have equation where we have t to the power 1 plus t to the power 2, then t to the power 5 plus t to the power 10, t to the power 15, and then they have coefficients, I can represent all together in form of y equal to dy by dt t, where dy by dt, now both are same in a way that at a particular point they are same. If I have some curve and at a particular point, if it touches a line, at that point line and that curve are same. If this line is dy by dt, then what is dy by dt at that particular lucky point t0? If there is a point lucky point t0, then what is the value of ft, that is t plus t square plus t to the power 10 and t to the power 20, that is ft. What is the value of ft? What is the value of ft when t equal to 0? Okay. Now, if I differentiate it as dy by dt, that ft, now f, okay, so f dash t or f, okay, if it is kind of single quote, okay, so kind of f and single differential df by dt. So if I calculate dy by dt or df by dt, whatever comes, okay, then whatever comes single quote, so whatever comes, if I get the value at point t0, then I have one scalar value. If I have a function ft equal to polynomial equation in any power, combination in any power, if I do df by dt and then all the t I replace with a scalar value t0, then altogether I get a scalar value. Now I have a line equation gt, where gt equal to dy by dt t. Now dy by dt, whatever scalar I have received when t was t0 in ft, if I place it, then I get scalar into t. This is the equation of line. Now both will be same at point t0. If I have a polynomial equation, if I have a polynomial equation, that polynomial equation, any polynomial equation, if I have a polynomial equation, that polynomial equation, can it be represented as a single line? If that is the case, then I have to differentiate the polynomial equation, and then I have to find the value of differentiation at a particular scalar point t0. Whatever I receive, that is dy by dt at t0. Now, if I draw a line gt, okay, I had polynomial equation as ft. Now, gt equal to dy by dt into t, then dy by dt is the nothing but whatever dy by df by dt I had received where t was t0, that scalar I have to replace. So now gt equal to dy by dt scalar into t. Now gt, if I gt, the gt is a line, gt is a line that will be tangent to the ft at touching ft at t0. Okay. Now I have ft equation, and if I calculate df by dt, if I have ft equation, if I calculate df by dt, and whatever the algebraic equation I am getting after the differentiation, I replace all the t with t0 scalar, and whatever we get, so dy by dt where t equal to t0, whatever scalar I receive, I remember it. Now I draw a straight line gt where dt equal to dy by dt t. The dy by dt is at t equal to t0, whatever I have received from ft, that I place there. Now I have a straight line gt equal to dy by dt, that is scalar t. Now if I draw the ft curve and gt line, it would touch that curve at point where t equal to t0. So I can say ft and gt are same. No one would say it is same. Ft goes to t to the power 20, where gt is only t to the power 1, but they are same at point t equal to t0. This is sometimes also called as linear approximation, linear local linearization. So if I have a curve and at point t equal to 0, if I zoom this curve at t0, then it would appear as a straight line. And this is the equation. There can be many things I can say. Local linearization, tangent, gradient line, whatever. Okay. So I could now replace the powerful polynomial function in a simple line, okay, where they are same at point t equal to t0. Can I proceed now? Now I have a polynomial equation. Can I represent in polynomial equation to the power 2? I represented it in a polynomial equation t to the power 1. You can say monomial, or you can say a tangential line, local linear regression line, whatever. Polynomial I represented through a single line. Polynomial can I represent through a polynomial with power of 2? Okay, same thing. Now we calculated dy by dt. Now I have to calculate d2y by dt square. If I calculate d2y by dt square, then I'll find the value d2y by dt square where t equal to t0. Whatever I get there. Now the gt equation is d2y by dt square into t square divided by factorial of 2. This is what we have got. So now I have full ft big polynomial equation as power of 2 polynomial equation, quadratic equation I believe. gt d2y by dt square, scalar value of ft d2f by dt square where t equal to t0. That is scalar value. I have to replace d2y by dt square into t square whole divided by factorial of 2. Can I represent any polynomial equation in another polynomial equation to the power 3? d3y by dt cube. I mean d3y by dt 3. We can do it. So gt will be now d3y by dt q. Q is 3, I believe. Yeah, q. Okay, square is 2. Q. d3y by dt q. T to the power 3 by 3 factorial. If that is the case, then this t to the power 3, whatever the polynomial equation we are receiving, it is not a straight line. It will be more approximation than a single straight line to the curve. So if ft is a curve and gt is another curve with t to the power 3, it will be more approximation to the actual curve. But certainly at point t0, they would touch each other. So if my polynomial equation is like this, suppose it is like this, then if I represent in straight line, then a straight line would touch it at point t0. Otherwise, error is very high. But if I represent in t to the power 3, then it would be similar one. The error, if it is at point t equal to t0, then they would touch each other. They are same. But beyond that, error would not be that much. If I have polynomial equation with power of 10, 20, and if I try to represent with a single line, the point t0 where it touches, there they are same. Otherwise, error is very high. If you see the difference in the dependent component, then error is very high. But if it is represented by t to the power 3, then at t0 it is same. But beyond that, error is less. So that is the concept. Okay. Now this is the idea. Now can we kind of visit again? If I have a kind of minima or